In this video, I am going to discuss about the half angle formulas for trig functions or trigonometric functions. We are going to start off with cosine of 2 theta formula. Cosine of 2 theta is equal to cosine square of theta minus sine square of theta. From this, we can rewrite it as 1 minus 2 sine square of theta, because cosine square of theta is equal to 1 minus sine square of theta. So I have cosine of 2 theta is equal to 1 minus 2 sine square of theta. Okay, so now what I can do, I can solve for sine of theta here. So if I simplify it, I'm going to get 2 sine square of theta is equal to 1 minus cosine of 2 theta, or sine square of theta is equal to 1 minus cosine of 2 theta divided by 2, or sine of theta is going to be square root of 1 minus cosine of 2 theta divided by 2. Now, what if we replace theta by theta over 2? It's the same thing, really. It doesn't make a difference. Theta is just some variable. So replace theta by theta over 2. Then I'm going to have sine of theta over 2. Here, by the way, it should be plus or minus. Sine of theta over 2 is equal to plus or minus square root of 1 minus cosine of 2 theta times theta over 2 is going to give me cosine of theta divided by 2. There you go. So this is the half angle formula for sine of theta over 2. Similarly, I could derive a cosine. So from this one, from the cosine 2 theta, so cosine 2 theta is equal to cosine square of theta minus sine square of theta. If I replace sine square of theta by 1 minus cosine square of theta, I get cosine of 2 theta is equal to cosine square of theta minus 1 minus cosine square of theta, which is just sine square of theta. So cosine of 2 theta is going to be cosine square of theta minus 1 plus cosine square of theta. That gives me cosine of 2 theta is equal to 2 cosine square of theta minus 1. Then I'm going to solve for cosine theta from here. So 2 cosine square of theta is going to be equal to cosine of 2 theta minus 1. Now if I divide both sides by 2, I get cosine square of theta is equal to cosine of 2 theta minus 1 divided by 2. And cosine of theta in that case is going to be square root of it, right? So square root of cosine of 2 theta minus 1 divided by 2, then again plus or minus. Like the sine case, we are going to replace theta by theta over 2. So that's going to give me cosine of theta over 2 is equal to plus or minus square root of cosine of 2 times, I'm replacing theta by theta over 2, so that's going to give me just cosine of theta. Cosine of theta minus 1 divided by 2. So that's, by the way, the second formula. Now, finding tangent of theta over 2 is piece of cake right now. So tangent of theta over 2 is going to be sine of theta over 2 divided by cosine of theta over 2. Now, sine of theta over 2 I found to be this. Cosine of theta over 2 I found to be this. Then I can just plug it in. That's going to give me plus or minus square root of 1 minus cosine of theta divided by 1 plus cosine of theta. And the 2's in the denominator are going to cancel out. So this is my final formula. So tangent of theta over 2 is equal to plus or minus square root of 1 minus cosine of theta divided by 1 plus cosine of theta. And that is the third formula that we are looking for. So what have we done here? We have derived the half angle formula for sine of sine. We have derived half angle formula for cosine, and then we have used these two values to derive half angle formula for tangent, because tangent is sine over cosine. And we used the formula cosine of 2 theta is equal to sine squared theta, cosine squared theta minus sine squared theta to derive all of this. I hope that this discussion was helpful. Thank you very much.